This is R.D. Sharma Solution Class 12 Chapter 7 Adjoint and Inverse of a Matrix. Exercise is 7.1. In order to have an idea about adjoint and inverse, the precursor is you need to know the determinant of A, how to find out the determinant of A and the matrix multiplication. This is the first question. Find the adjoint of the following matrix. And there are questions which will be coming. Those are just the repetition, same type. So please understand it very well. This is 2 by 2 matrix. So when you have a 2 by 2 matrix and this is a square matrix means row is equal to column. There are 2 rows and there are 2 columns. So this is 2 by 2 row and column equal matrix. So when we are in a process of finding adjoint A, 2 by 2 is very simple. We have -3, 5, 2 and 4. How to do this? It's just interchanging like this. See. So we have to exchange 4 and -3. So just put it here. 4 here and -3 here. So exchanging the diagonal element. And what about the 5 and 2? This is your A. This is your adjoint A. So this 5 and 2, what you have to do is, you have to change the sign. So 4 and -3 has been exchanged and 5 and 2 negative sign. So there are 3 things which we need to verify. Adjoint A we have already found out, A already found out, so you can do always the multiplication. So I told you, you need to know the matrix multiplication. I'll do one of it. So 4 -5 -2 -3. And this is going to be adjoint A, and I am multiplying adjoint A with A. This is adjoint A. And what is our original matrix? We are doing the first one, right? So this is -3 and we have 5 and 2 and 4. Okay. 4 into -3 -12, -5 into -2 -10. 4 into 5 is 20 minus this -5 into 4 is -20. Then -2 into -3 is 6. And -3 into 2 is -6. -2 into 5 is -10. -3 into 4 is -12. So what it is going to be? This is -22. And this is going to be 0. This is 0. This is -22. So this is what you got. So adjoint A multiplied by A is this matrix. Similarly, we have to find out the determinant of A into I and A into adjoint of A. So determinant of A you need to know, means this is a precursor. So this is adjoint A. Let me just show you adjoint this determinant of A, because 2 by 2 determinant is not that hard. So 4 into -3 minus 5 into 2. So 4, this is A, okay? 4 into -3 -12. 5 to 2 is 10. So this is -10. So we have -22 as the determinant of A. Now multiply it by identity matrix. 2 by 2 identity matrix I am writing. Now this is a scalar multiplication. Take -22 inside, multiply with every element. You get this same as the previous one. So these two we have equated. I hope you got the idea. And the second one is just, you need to interchange adjoint A and A. That is, first write A, -3, 2, 5 and 4. And you multiply it with adjoint A. Adjoint A was 4 -5 -2 -3. And when you multiply it, -3 into 4 is -12. 5 into -2 is -10. And -3 into -5 is 15. And 15 plus, actually it will be plus, but 5 into -3 is -15. So I'm taking the first row and the first row of the first matrix and the second column of the second matrix, and I'm multiplying each corresponding element and then adding. So -3 into -5 is 15 and 5 3 is a 15, -15. So this is what you got. So you have this, you can write it like this only. So basically what I'm trying to suggest here is you are going to get a 0. So 15 minus 15 is 0. Now 4 to the 8 and minus 4 to the 8. Now minus 10 here. 4 3 is a 12 minus 12. So what did you get finally? This is minus 22. This is 0. This is 0. This is minus 22. The third also has come as the same one. So we have verified. We have verified all of these three. Now this question which we just did, all of the questions which are coming, they are just the repetition. So I'll just give you an idea here. This is A, B, C, D, and previously we have already done a example with actual values. So this is a generalization, and that was actually the implementation. So I'm taking the adjoint. So A and D I'm interchanging, and C and B negative sign. So all these you are able to do. Adjoint A I have found out and told you. Now you can do this. Same here. Same thing here, but since we have sine and cos, I'll try to do one of it. Because adjoint A, let us find out adjoint A is what? Cos alpha you need to interchange, and that doesn't bother because they both are cos alpha. And change the sign of sine alpha. So minus sine alpha here. Okay. Now everything you will be able to do. I'm just going to do the one of it. Say let us do A into adjoint A, because adjoint A into A you can do determinant of A into I, you can do A into adjoint A, you can do. So I'll take one of it and I'll give you what you have to get for all of it. So cos alpha, sin alpha, cos alpha. This is A, and I'm just using a shorthand. Adjoint A, let's write cos alpha minus sin alpha, and here minus sin alpha and cos alpha. Okay. Multiply cos alpha is cos square alpha. This is minus sin square alpha. Then we have cos alpha minus sin alpha is minus sin alpha cos alpha. And then we have sin alpha cos alpha plus sin alpha cos alpha. Okay. Now second row, first column, sin alpha cos alpha and minus sin alpha cos alpha minus sin alpha cos alpha. Okay. And then we have second row with the second column. So minus sin square alpha and minus plus cos square alpha. Okay, this is 0, this is 0. This is cos square alpha minus sin square alpha. So c square minus s square I am writing. 0, 0, cos square minus sin square. Okay. So these all you can do, because this is just the question repetition which we did, and as I mentioned you, determinant of A you need to know, and matrix multiplication also you need to know. Otherwise you have to go back and try to see the previous exercises. Here we have same thing here, 2 by 2 matrix. Okay, there is no difference. So adjoint A is quite simple. Let's do this middle one now. Okay, determinant of A also we'll find out, and multiply with the identity matrix that we are going to do. So this is, let's see the adjoint also. Adjoint A is simply you need to exchange the diagonal element 1 1, and then you have to change the sign of the other element. So you just interchange 1 1, so it won't change anything, but this sign you have to change. Tan alpha by 2, here negative tan alpha by 2 minus tan alpha by 2. Okay, now this we are doing. So we'll try to find out the determinant. So I am taking the determinant. It will be 1, means this 1 into 1 is 1, minus tan alpha by 2, tan square alpha by 2. Since it is negative, it will be 1 plus tan square alpha by 2. So tan square alpha by 2. Okay. And this is determinant of A, and multiply it with the identity matrix. 2 by 2 identity matrix is what? 1 0 0 1. So final will be multiply each element inside with 1 plus 10 square alpha by 2. 1 plus 10 square alpha by 2, 0 1 0 0 1 plus 10 square alpha by 2. This is what you are going to get from adjoint A into A also, and A into adjoint A also. So this is going to come for all of it, all the 3 1. Okay. Now compute the adjoint of the matrix, and we have already seen the 2 by 2. This is a 3 by 3, and we have to verify also. So we have to find out the cofactors, and then, because cofactor is important, because we need to find out the cofactor matrix, and then we'll take the transpose, and that transpose of a cofactor matrix is the adjoint A. So let us see this. Let me write it here. 1 2 2, 2 1 2, 1 2, and 2 2 1. So this is here. Now let me equate it. Because if you equate, or you can write it somewhere, then that the computation will be quite easy. There are 3 rows, 3 columns. So let us identify it or indicate it using A11. So I'm not writing A11, but basically C11, because we are going to find out the cofactor. C11, C12, C21, C22, C23, C31, C32, C33. Now why I have written this? Because when we are trying to find out the cofactor, that is C11, cofactor 11, so minus 1 to the power I plus j, I is 1, j is 1. Because in cofactors sign will come. Minors with sign is cofactor. So this row and column you have to leave for C11. So C22, C23, C32, C33 you have to write. So it is 1, 2 and 2 and 1. Okay. So what is the value here? 1 minus 1 to the power 1 plus 1. Please remember minus 1 to the power even will always be 1. Minus 1 to the power odd will always be negative 1. Okay. Minus 1 to the power 1 plus 1. It is going to be plus 1. So the internal one is 1 minus 2 to the 4. So it is going to be negative 3. Let us take one more of it. C11 we have found out. Let us take any cofactor with a negative sign. How? We'll take C32. So C32 is what? It is C32, and this is going to be minus 1 to the power 3 plus 2, and row and column intersecting at C32 will be left, and remaining will write 1 to 2 2. So minus 1 to the power 3 plus 2, that because it is odd, minus 1 to, it will be negative 1. This is going to be 2 minus 2 to the 4. So it will be negative 2. Negative will become positive, so it is going to be 2. So you have to do it for each and every element, right? So each and every element you have to do. I have given you an idea for 2 elements, C11 and C32, but you have to find out, because there are 7 more, 9 values will come. Now I hope you will be able to do it. Now adjoint A is the cofactor matrix transpose. So I am writing the cofactor. So this is the cofactors. All the cofactors I am writing. Now, in order to find out the adjoint A, we will take the transpose of this matrix. We already got the cofactor matrix, which I suggested you. We will take the transpose of this. Transpose of this means row and column you have to transpose. Row you have to make column, column you have to make row. And that is going to be your adjoint A. I'll just show you here. This minus 3, 2, 2 row will become the column. 2 minus 3, 2 is going to become a column. 2 minus 3, 2. 2, 2 minus 3, this row is going to become a column. 2, 2 minus 3. So this one is your adjoint A. Now adjoint A multiplied by A into adjoint A, and determinant of A into I. That you have to do. So all of this you have to do. As I said, matrix multiplication and determinant, how to find out that you need to be very careful and need to know that. Then only you'll be able to understand. So we can take any of this. So this A into adjoint A into A, this is some simply multiplication of these two. One matrix is already given, second matrix we found out. Adjoint A we have found out and A is already there. So it's just a multiplication. Okay. Now adjoint A into A we are doing. So adjoint A I'm writing first. This is adjoint A, I'm just writing here, and we are multiplying it with A. I'm going to show you how actually it will be done. Those who know the multiplication, they can just proceed. So I'll just show you the first column, what will come, because we are short of space. So minus 3 into 1 plus 2 into 2 plus 2 into 2. So minus 3 into 1 is minus 3, 2 into 2 is 4, and 2 into 2 is 4. So 4 plus 4, 8, minus 3 is 5 here. So as I said, just let us do the column only. Others you will be able to do. So I'm taking the second row and the first column. 2 into 1, 2. Minus 3 into 2, minus 6. 2 into 2, 4. So 4 minus 6 plus 2. That is going to be 0 actually. Now third row and first column. 2 into 2, 1. 2 into 2, 4. And minus 3 into 2 is 6. Now this, whatever you will get, I hope you will be able to do it. I'll show you the only first column. It is going to be 5. This is going to be 0. This is going to be 0 again. And rest I'm just writing 0, 0. And this is the diagonal will be 5, others will be 0. So it's basically a scalar matrix with 5 at one's place. Now determinant A, so we can find out the determinant also. First I have already done adjoint A into A, and then determinant of A we'll find out. We'll open it using the first row. So 1 into something, that is the minor will come here, minus 2 into, well, you already have a cofactor, so you can directly use it. You can directly use it. C11 plus C12 plus C13. Right? C1 means 1 into C11 plus 2 into C12 and plus 2 into C13. That you have to do. But I am just opening it in a normal way. First row. And I am writing the minors inside. So 1 into 1 minus 2 is a 4. So 1 minus 4 is minus 3. This is cofactor also, minus 3 you see. Minus 2 and then 2 minus 4. So minus 2 it will be. Plus 2, 2 to the 4 minus 2. 4 minus 2 is 2. So minus 3 plus 2 to the 4 plus 2 to the 4. So 8 minus 3 is 5. The determinant is 5. Now multiply it with the identity matrix. What is the identity matrix? 3 by 3 identity matrix, 1 0 0 0 1 0 0 0 1. So this is the identity matrix. So this is 5 into I, which is actually multiplication of 5 with this identity element. It is going to give you 5 0 0 0 5 0 and 0 0 5, which is actually equal to what we just got when we actually multiplied adjoint A into A. A into adjoint A, I hope you'll be able to do. Now we have a 3 by 3 square matrix. We have to show that A multiplied by adjoint A is a null matrix or 0. This capital 0 represent all the elements will be 0. So first we'll try to find out the adjoint A. Then we'll do the matrix multiplication. I hope you remember that how to do this. The cofactor we have to find out. Then we have to write that in the matrix form, and then we have to take the transpose. That is the adjoint. So I am just marking it so that I can give you some idea about how to, just as a recall. So these values we are going to find out, and few of these I am going to tell you. For example, C31. What will be C31? So we have to forget about those row and column where this 831 intersect. -1 1 3 0 will come, and there will be -1 to the power of the I plus j, that is 3 plus 1. So -1 to the power 4 is what? It is going to be 1. Always -1 to the power odd is -1 to the power even is always 1. So let us find it out. -1 into 0, 3 into 1, you subtract it, it will be going to be -1, -3. So this is -3. Let us take one more of it. I am taking C23, and C23, it will be this row and this column where A23 intersection is there will leave, and 1 18 -1 2 will write 1 into 2 -18 into -1, that is going to be 20. Since we have a -1 to the power 3 plus 2 or 2 plus 3, so it will be -1 to the power 5, and -1 to the power 5 is -1. So write it negative here, -20. Okay, all of these you have to do. I just gave you an idea how to do this. So finally you will arrive at this matrix. This is still not adjoint, okay? So I'm writing that matrix just to let you know that this is the cofactor matrix. Now you have to take the transpose of this matrix. That is, row you have to make the column, and column you have to make the row. Then only adjoint A will come. So this 30 -20 -50, which is actually the row, is going to be the column. It will become the column. So I'm writing it here: 30, -20, -50. Then we have 12, -8, -20, and -3, 2, and 5. So this is what? This is the adjoint. So we have to multiply A with adjoint A. Now I already told you that matrix multiplication you need to know if you need to know the adjoint A and inverse. So we multiplied it. When you multiply, you will see it will be a null matrix 0. So 0 0 0 0 will come. Let me tell you again, you need to know minor, cofactor, multiplication of matrix, determinant of A. All this you need to know before doing this exercise. So this is kind of a same question. I'll just give you an idea here. So this is matrix. We have all the cofactors. Then this is adjoint A. And then that is the cofactor matrix. Transpose is adjoint A. And that will come as the original matrix which is given to you. Now this matrix we have to show that adjoint of A is thrice that of A transpose. This A raised T is nothing but the transpose, row to column, column to row. So let me just do this thrice of A transpose so that you understand what we actually need to get when we find out the adjoint A. So this is the original matrix I am writing, and first I am taking the transpose. So I am taking the transpose, row to column I am making. So all these I have written row to column, and just multiply it with 3. What do you get? -3, 6, 6, -6, this is 3, and -6, this is going to be -6, -6, and 3. So when you take the adjoint A, this is going to come exactly like this. So I'm just giving you an idea. You have to find out the cofactor matrix as I suggested. Then you have to take the transpose of that matrix, that this will come, and these two are exactly similar. Or you can say you can take thrice out of adjoint A, that is going to be equal to the A transpose, right? Find A into adjoint A for the matrix A. So this kind of question we have done already. So I'm just giving you a hint. I would encourage you to try this and have a look at the answer only when you have any problem in computation or calculation. Otherwise, please do it by yourself, because maximum you do by yourself, then only you will be able to do in the exam, and this will be quite easy for you. Find the inverse of the following matrix. Now this is a 2 by 2 matrix. So here you will understand how to take the inverse of a 2 by 2 matrix. First of all, we need to find out the determinant. Whether determinant is 0 or not, that will decide what we have to do. So just cross multiply cos into cos, that is going to be cos square theta, and sine into sine in sine square theta. We have a negative sign, so we already have a negative sign, so minus minus will become plus. So cos square theta plus sin square theta is equal to 1. So this determinant is not equal to 1. So A is a singular matrix. Singular matrix, that means determinant is not equal to 0. Non-singular means determinant has to be 0. Therefore, this matrix, which is a square matrix, this is invertible because A is a singular matrix. So we'll try to find out the cofactor. Let me just write it here. Cos theta, sin theta, negative sin theta and cos theta. Okay. So let me mark it here because actually we are going to find out the cofactor and then we'll take the transpose of the cofactor matrix. This is C11, this is C12, C21, C22. So C11 is what? Minus 1 to the power 1 plus 1, and then we leave this row and column where this C11 intersect, only cos theta will remain. Let me write it directly, minus 1 to the power 2 is 1 only, it is going to be cos theta. Now C12 we are finding. It will be minus 1 to the power 1 plus 2, and then row column we leave, we only get minus sin theta, negative sin theta. So this is minus 1 to the power 3, and that is going to be negative, negative become positive, so sin theta. C21 is minus 1 to the power 2 plus 1, and we leave this row and column where it intersects, only sin theta will remain. Now, negative 1 to the power 2 plus 1 will be negative. Okay, so it will be minus sin theta. Now we are doing C22. So this row and column leave, you just get cos theta. So minus 1 to the power 2 plus 2 is plus 1 only, so I'm not writing it. Okay, so now this cofactor matrix you have to write first. In place of C11, write cos theta. In place of C12, write sin theta. In place of C21, it will be minus sin theta. And C22 is going to be cos theta. Okay, now this is a cofactor matrix. We have to take the transpose in order to get the adjoint. Row to column, column to row, that is what. So this cos theta, sin theta will become our column. So cos theta here, sin theta here. Then this also we have to make as minus sin theta and cos theta here as a column. So this is your adjoint A. This is actual adjoint A. Now, in order to find out A inverse, the simple formula is adjoint A divided by the determinant of A. Adjoint A is already there, determinant of A we have already found out. In order to find out the singular or non-singular, that is going to be 1. It won't affect. Anything divided by 1 will be the same. So this is your answer. Okay. So even if you divide it by 1, it will be same. So 2 by 2 inverse this is. Now find the inverse of the following matrix. Now this will be quite easier for you because we have done a trigonometric version. Now it's simple. It's not a identity matrix, please remember, because there is the diagonal has 0, 0. Okay, so when we take the determinant, it is going to be negative 1. Negative 1 is not equal to 0. So let us take the cofactors and then take the transpose and divide it by the determinant, that is going to be negative 1. So this is the answer. Now we have to find out the inverse of this matrix. So we have this determinant A into 1 plus BC by A minus B into C. So A gets cancelled, 1 plus BC minus BC gets cancelled, you get 1. So determinant of C is going to be 1. C is a singular matrix, it is invertible. Now when we take the cofactor matrix, you just take the transpose divided by 1, because the determinant will be in the denominator, adjoint will be in the numerator, and that will be your inverse. This is the final answer. Find the inverse of the following matrix. We have already done question like this. I'm just moving ahead because this is just practice. You have to just practice again and again and again so that you get all those things in tips. So you can do it faster. So this 17 is showing that it is a singular matrix. So whatever answer comes or adjoint comes, you just divide it by 17. Don't take it inside. Find the inverse of the following matrix. Now this is a 3 by 3 matrix. It's a square matrix. So we have a simple formula here in order to get the inverse. A inverse is nothing but the adjoint of A. So we'll take the adjoint of A and divided by determinant of A. Determinant of A. So in order to compute the inverse, let us see what is the determinant, because determinant is very important. If it is 0, then inverse have a different kind of discussion. But right now, if it is 0, not possible. So I'm just opening it using the first row 1, 2, 3. So 1 minus 2, 3 will come, and I'm just leaving the rows and column at 1, at 2 and 3, and other things I'm writing here. So what will be the 3 to the 6 minus 1? So 5 it will be, minus 2 to the 4 minus 3 is going to be 1, 1, 2 minus 2, 2 minus 3 to the 9, this is going to be minus 7, 7 3 minus 21, 7 3 is a 21. So you get my 5 minus 23, and that is going to be negative 18. So negative 18, since it is not equal to 0, we can proceed with the inverse because we have singular matrix. Okay, so we will find out the cofactor matrix first. That cofactor matrix will be the final one, just a step before adjoint A, because if I am writing C11, C12, C13, C21, C22, C33, C31, C32, C33, all of these cofactors you have to find out. Let me take a few of these. Let us take C11. Minus 1 to the power 1 plus 1, what will be there? Leave that row and column where 1 lies, and then we have this 3, 1, 1, 2. So let me write it here. We have 3, 1, 1, 2, and this is, see, negative 1 to the power even will always be plus 1. Minus 1 to the power odd will always be negative 1. So it will be 5 here. So let me take few more of this so that you get the idea. C22 and C32 will find out, because the 9 cofactors you have to find out, please remember. So minus 1 to the power 2 plus 2 here, minus 1 to the power 3 plus 2 here. So C22 will be positive, C32 will be negative. Now what will be inside? 2, just leave the row and column with 2, 2, 1, 3, 3, 2 will come. So 2 minus, this is a 9, this is going to be negative 7. Minus 7 here. And minus 1 to the power 5, it is going to be negative. And C32. So third row and second column, just leave this, and other value just write it here. So please remember, minor plus the sign is cofactor. So we are just leaving this. We are writing 1, 2, 3, 1. 1 minus 3 to the 6. It is going to be negative 5. Negative 5, and there is already a negative sign outside. Minus 1 to the power 5 is going to be 5. So you see the values. C11 was 5. C22 is a negative 7, and C32 is 5. So I hope you will be able to find out all of these. So final matrix will be something like this, which I am writing here. This is the final matrix. I just want you to recheck it. I want you to find out each and every cofactor. Now this is the cofactor matrix. We will take the transpose of this matrix. Transpose is what? Row to column, column to row. So 5, negative 1, negative 7. This is minus 1, minus 7, and 5. This is going to be negative 7, 5, minus 1. Negative 7, 5, minus 1. Okay, this is your adjoint A, adjoint of the matrix. Now remember, we already found out the determinant. So inverse is adjoint A divided by the value, which is going to be minus 18. So if there is a multiple of 18 inside, you can always take 18 inside, but it is not required. Okay, find the inverse of the following matrix. This is also a 3 by 3 matrix. We already seen how to do this. I explained you just now. So just go ahead with this. So you just have to find out the cofactor matrix, take the transpose divided by the determinant of the matrix, which is 27 in this case, and the final answer will come. So one more here. Please remember, there is always problem while you are doing an examination. negative sign and positive sign, what we have to, so that has to be very keenly taken care. Same thing here, same kind of question. So I'll just show you the answer, and I'll just encourage you that you do it by yourself first. All these questions same. Just I'm just pushing forward, because the criteria and the logic and the way it should be done is same. Here also, find the inverse of the following matrix. This also you have to do the same way. Take the determinant, take the adjoint, divide both of them, and then you get the inverse. Now find the inverse of the following matrix. Now same thing you have to do. Just remember, when you are doing it, there can be some formula which can be employed. The trigonometric identity or some negative and positive sign. That may be some certain error that you have to really see. Means identity you must use, a negative positive sign you have to be very considerate about this, because this cos sin alpha always creates that kind of issue. So this row I am opening, I am not writing 0 0, only 1 I am writing, because eventually it will be 0 0. So I am just writing this one. So cos alpha, here sin alpha minus cos alpha, so it is going to be minus cos square alpha. This is going to be minus sin square alpha. You can take negative outside. Sin square plus cos square is 1. So sin square plus cos square is 1. So it's going to be negative 1. Okay. So you get the negative 1 as your determinant. So I hope you'll be able to find out the adjoint. Just divide by negative 1. That means multiply inside by negative 1. Change the sign. That is. Find the inverse of the following matrix and verify that A inverse into A is equal to I3. A inverse we already know how to find out, and we multiplied by A, it should get I3. I3 is nothing but 3 by 3 identity matrix. That means we have a 3 by 3, 3 rows, 3 column, and in the diagonal it will only be 1, else it will be 0. So A inverse you already know how to find it out. Just to recall that these values, every value, the cofactor has to be found out. Once the cofactor are found, then these values are to be placed in the place of the value for which the cofactor has been found. And cofactor will always take the sign, that is minus 1 to the power I plus j. I and j are the row and column. For example, let us take the first one. It will be 4, 3, 3, 4 minus 1 to the power 1 plus 1. So 16 minus 9 is 7 here, and minus 1 to the power I plus j, 1 plus 1 is nothing but 1 minus 1 to the power 2, that is going to be plus 7. So this is how we have achieved 7. All of it you have to do for the 9 values, and then you have to take the transpose of that matrix. Row you have to change to the column. Once it is being done, this is called the adjoint of A. Now you have to divide this adjoint of A by the determinant of A. Determinant of A is 1. So I'm not computing it, just telling you to go through it. The determinant of A will be 1. So A inverse will be adjoint of A divided by determinant of A. So this is the A inverse. Now you have to multiply this A inverse with the actual A which is given in the question. Identity matrix will come. So this question is exactly the previous one we did. The same procedure need to be followed. For the following pair of matrix, verify that AB inverse equals B inverse A inverse. So you see this question, the next question, and the next question, that is this one also. It is one of the part of the what we will do in the this question which I'm talking about. So we'll try to do this question properly so that the next two question gets covered. So AB inverse. First we have to multiply A and B. Then we will take the inverse. Then we will take the B inverse, A inverse, and then we will multiply them. So A into B. So matrix multiplication is the precursor. You need to know it before going ahead with adjoint and inverse. So multiplying these two matrices A and B. So the row has to be multiplied with column. So 3 into 4 plus 2 into 3. Then 3 into 6 plus 2 into 2. This is the first row. Now Both columns are done. Now the second row with both the columns. So 7 into 4 plus 5 into 3. Here 7 into 6 plus 5 into 2. Okay, this is the matrix multiplication. This is 12 plus 6. It is going to be 18. 7 4 is a 28 plus 5 3 is a 15. So 28 plus 15 is 3 and 4. 43 it will be. Then the next one, 6 3 is a 18 plus 2 is a 4. 18 plus 4 is 22. 7 6 is a 42 plus 5 is a 10. It is going to be 52. Now this matrix is simply A into B. We have to take the inverse of this matrix. Inverse is what? First we have to find out the adjoint. So A into B basically it is. By itself it is single matrix, but it was the result of A into B. Adjoint of A you have to replace, or you can say exchange these two values, 18 and 52. And then you have to change the value of minus 22 and minus 43. These sign has to be changed. So this is your adjoint AB, but still we need to find out the inverse. This is the adjoint. Now adjoint AB divided by determinant of AB is going to give you the AB inverse. So 52 into 18 minus 43 into 22. Let me tell you the value, you can compute it. It will be negative 10. I'll give you the answer. It is negative 10. This is the solution on the back side. But let me tell you it is minus 10. So now adjoint AB has to be divided by the determinant of AB. So minus 1 by 10 it will be. So this is your final value. Now coming to the right hand side. In the right hand side, B inverse, A inverse has to be computed. I'm going to multiply. So B inverse will be, I'm doing it here only, 4 and 2 has to be exchanged. I'm trying to tell you the 4 and this 2 exchange, 6 3 same change sign, that is going to be B inverse. So 2 and 4 I have exchanged. The sign I'm changing, minus 6 minus 3. So this is your adjoint B. And what you have to do, multiply it by, this is the determinant, 4 into 2 minus 6 into 3, 8 minus 18 minus 10. So minus 1 by 10. This is going to be the B inverse. Now this is going to be B inverse. Now coming to A inverse. This is 3 and 5 you need to exchange the places. And then change the sign of 7 and 2. So 5 and 3 have exchanged, minus 7 minus 2. So this is the adjoint of A. Now determinant of this will be 5 into 3, 15, minus 7 is 14, it is going to be 1. So it won't affect, even if you divide it by 1, it won't affect. The adjoint of A is actually the A inverse, because the determinant is A. Now let us multiply these two, B inverse, A inverse. So I'm multiplying it here, 2 into 5 plus 7, 6, 42. Now 2 into 2 and 6 into 3 along with the sign. Just keep an eye on the sign also. Minus 3 into 5 plus 4 into minus 7. Just take minus because there is already a minus. Okay. Now minus 3 into minus 2. And this is going to be 6 plus 4 is 12. This is going to be 10. 10 plus 42, 52. And this is going to be minus 4. Minus 18 minus 22. Minus 15 minus 28, that is going to be minus 43, and 6 plus 12 is 18. So this is B inverse A inverse, and minus 1 by 10 was already there. If you see, these two are exactly similar, so the equality is verified. So I'm just cleaning it and I'm going to show you the proper result. So if you're doing it in your exam or in your classwork, you have to do exactly like this. Means you have to write everything like we have AB is invertible. You have to check A, B, the determinant also. So this not equal to 0, this has to be find out, because the singularity has to be checked, non-singularity has to be checked, because this comes when the inverse have to be found out. See, this is not equal to 0, this is not equal to 0. These are the basic things you have to do, and you have to write all so that the examiner can understand. So as I said, the previous question exactly similar like this. So I hope you will be able to do this in the line of what we have already completed. Okay, so I'm just going ahead, and this is one of the part of what we have done earlier. So you can multiply these two, take the inverse, and the result is in front of you. Let me tell you that when you take the AB determinant, it is going to be -2. So you take the adjoint and divide it by -2. Next one is A is given, A inverse, show that this thing. So A inverse, let me just do it. 7, 2 you have to exchange, and you have to change the sign of 4 and 3. So it is 3, it is 4. Now divided by the determinant of A, it's going to be 7 is a 14 minus 3 4 is a 12. So it is going to be 1 by 2. This is going to be your A inverse. So adjoint A we have found out, and then divided it by the determinant of A. Now this is 2A inverse, so twice of this, 1 by 2, 7 by 7 and 4, 3 and 2, and 2 gets cancelled. So whatever on the right hand side, you should get 7, 3, 4, 2. So let us do it. 9 identity matrix, since it is 2 by 2 matrix, 1 0 0 1 will come, minus A. What is A? This is 2 minus 3 minus 4 and 7. So it is going to be scalar multiplication, 9 0 0 9. Then you have a subtraction, 2 minus 3 minus 4 and 7. Okay, 9 minus 2 is 7, 0 minus of minus 3 is 3, 0 minus of minus 4 is 4, 9 minus 7 is 2. Okay, these two are exactly similar. This is how we have to do it. So how we have to write, this is I'm just giving you an explanation and the logic how we have to do, but this is how you have to do in your examination. These are the steps you have to write now. LHS, RHS has proved this, all you have to write. Okay, this question, you just have to find out A inverse. A is already given, identity is 1 0 0 1. So you can just put all these value here and just check left hand side is equal to right hand side or not. Okay, so I'm just giving you the idea that 1 and 4 has been exchanged, 5 and 2 the sign has been changed, and the determinant will be 4 minus 5 to the 10 is going to be minus 1 by 6. So this is going to be your A inverse. Put it here and put it at the place of A inverse where you have, and I'll just show you how you have to do it. You can just recheck it once you are done. I encourage not to see the answer before. Now next one is also something like this, but since we don't have numbers, we have A and B, etc. We'll do it. A into A inverse. Let us find out the A inverse. Exchange the diagonal values. So 1 plus BC by A here, and then we will get A here. B and C sign we need to change, minus B minus C. Okay. Now multiply it with A. Multiply this. We have just found out the adjoint, and we have to find out the determinant. So we have to find out the determinant also. A into 1 plus BC by A minus BC. The A gets cancelled. 1 plus BC minus BC it will be. So BC gets cancelled. You get 1. So it won't affect. The adjoint is only the final A inverse, because determinant of A is 1. Now multiply this with A, because we are doing first we'll perform the left hand side and we'll try to equate it with the right hand side. So this is multiplication with A. Let us multiply this with A. 1 plus BC, A gets cancelled. This is going to be minus AB. This is going to be minus AC. This is going to be A squared. This is your left hand side. Now coming to the right hand side, so RHS will be A squared plus BC plus 1 multiplied by identity matrix. You have 1 0 0 1 minus A into capital A. So multiply it with A and then write it here. A into A is A squared, A into B is AB, A into C is AC, A into 1 plus BC by A gets cancelled. You only get 1 plus BC. Okay. Now this is simply a scalar multiplication. The last question we did 9 into I, like that. So A square plus BC plus 1, 0, 0, A square plus BC plus 1. And then you have a negative sign here. A square AB AC 1 plus BC. Now let us subtract it. A square plus BC plus 1 minus A square. A square gets cancelled. You get 1 plus BC here. Then you have 0 minus AB here. 0 minus AC is minus AC. A square plus BC plus 1 is minus 1 plus BC. BC plus 1 gets cancelled. A square it will be. So you see these two left hand side, right hand side are equal. So I'm just giving you the actual result. This is how you have to do it. This is the step by step you have to follow. We have so and now LHS, RHS, hence prove. These all you have to write in an arranged and disciplined manner. That will be the answer. Now AB inverse we have to find out. Now let me show it here also, because you already know how to find out the inverse. A and B inverse is given. So we have already seen just now in previous question, there is a property that A into B inverse is equal to B inverse A inverse. Right? A and B inverse is given in the question. So AB inverse, we already saw in the earlier questions, AB inverse is equal to B inverse into A inverse. Right? Okay. Now AB inverse, we have to find out. So B inverse is already given in the question. A inverse we have to find out. So this is 3 by 3 matrix. I hope you will be able to do it because we have already done the question like this. So you have to find out the cofactor matrix here. In place of 5, you have to write the cofactor of 5. In place of 0, cofactor of 0 like this. Cofactor is nothing but you just forget the row and column where that number is and take the sign minus 1 to the power of I plus j. Now take the transpose here. And then when you take the transpose of the cofactor matrix, that is going to be the adjoint A. Determinant of A, I am not doing it, but I am telling you it's going to be minus 1, negative 1. And all the signs you are going to change because minus 1 division or multiplication, that means the sign needs to be changed. So all the signs will be changed. That is going to be your A inverse. And now since B inverse is already given in the question, A inverse you have found out, just multiply these two. You already know how to multiply two matrices. That is going to be your B inverse A inverse, and that is going to be equal to AB inverse, and that will be your final answer. B inverse A inverse is simply equal to AB inverse that you need to compute in this question. Basically, matrix multiplication is important here. Now this question is exactly similar to what we have done just now. F alpha, G beta, there is nothing different. They are just like matrix A and B. So F alpha inverse is basically, if you just assume it to be A, you have to find out A inverse. And that is going to be equal to F minus alpha. Minus alpha means in place of alpha, you just have to replace it with negative alpha and use the property or properties of trigonometry or trigonometric identities or relations. So F alpha, now when you put negative alpha in place of alpha, what do you get? So F minus alpha, in place of alpha I am putting minus alpha. You see here, this is going to be in all the three parts, 1, 2, 3. So cos minus alpha minus sine, in place of alpha write minus alpha, it is going to be 0, 0, 0, 1, sine negative alpha, cos negative alpha, 0, 0, okay. Now cos minus theta is cos theta. So cos minus alpha will be cos alpha. Sine minus theta is minus sine theta. Minus is already there outside. So you have sine theta. 0, 0, 1. Sine minus alpha is going to be minus sine alpha. Cos minus alpha is cos alpha, 0, 0. So this is going to be your F minus alpha. So when you will take the inverse of this matrix, you need to get this matrix which we just got. And I hope you'll be able to do the inverse, because inverse we have already discussed. I'll show it to you here for you to observe the result. So you will take one element, find out the cofactor of it, and then replace all the 9 values with the cofactor which you see here. So once you get the cofactor matrix, you have to transpose. So all these C11 till C33, all these values needs cofactor, and cofactor will always have the signature sign, and that sign will be minus 1 to the power I plus j. So all this value you have to put it here, and then you have to take the transpose of this. Once you take the transpose of this, that is going to be divided by the determinant. Once you find out the determinant, if you want, I can find out the determinant also. Let us see. You can open it using the third row or the third column. I am going to open it using the first row. So cos alpha, and since we already have the cofactor, you can directly replace it. Okay, it is going to be cos alpha inside, that is cos alpha 0, 0, 1, that is going to be cos alpha. And then we have minus already, so we have this is C12. Let us see C12 here. So you have a minus sin alpha, this was already minus become plus. So let me replace this negative with plus. So cos square, as I said, minus was there, so it will be cos square plus sin square, and sin square theta plus cos square theta is going to be 1. The determinant is 1. So divide this matrix, that is the adjoint of f alpha, divided by 1, and that will be exactly similar to this one. Okay. Now same thing you have to do for the second part. Do it for G beta. G beta is simply, you can assume it to be a B matrix, and same thing, same scenarios, same logic, or same way you have to do. Okay, because cos minus alpha, remember cos minus alpha is cos alpha, and sin negative alpha is going to be minus sin alpha. This you have to apply it here. Cofactor matrix we have just seen how to find out, along with the sign, because cofactor is all about signs. Minor with sign is cofactor. Then you have to take the transpose divided by the determinant. Determinant is going to be 1. The next one is f alpha into g beta. So you have to perform the multiplication here. F minus alpha, g minus beta, you have already computed in the two parts. So you just have to multiply the f minus alpha with g minus beta. I hope you will be able to do it. Then f alpha into g beta, you have to compute f alpha into g beta and take the inverse. I hope you will be able to do it. Now this type of question, there are many questions like this, and the way of doing it is almost similar. So we'll do this question properly, because we have already a, and a squared is simply multiplication of a with a. Identity matrix, it is 2 by 2, it will be 1 0 0 1, that is the diagonal will have one value, and 0 is of course a null matrix, 0 0 0 0. So we have to calculate the A inverse. Now these are the questions which are following. So we need to find out A inverse, here also A inverse. So there are various questions. So let me do this question properly so that you are comfortable in the next questions. So what we'll do here is, this is A, and we'll multiply A with A, that is A square we are going to find out. So this is A, 2 3 1 2. This is also A into A we are doing 2 3 1 2. So A squared we are interested in. So 2 into 2 is 4, 3 into 1 is 1, 3, so 4 3, 2 3 and 3 2, then 1 2 and 2 1, and then 1 3 and 2 2, multiplied and add. So this is A square. A square will be what? It is going to be 7, this is 12, this is 4, and this is 7. A square. Now we have to put this in this expression or identity. So I am putting A square here, then subtraction with 4 into A. A is this matrix, so we'll multiply this with 4. So 4 to, I'm multiplying it with 4 and then writing 4 to the 8. Let me write it here. So 4 to the 8 here, 4 3 is 12, 4 1s are 4, and 4 2s are 8. So this is minus 4a. What is the identity matrix? This is simply 1 0 0 1. This is the identity matrix. Okay. So this is equal to 0. So now you can very well see, if you take the corresponding value, 7 minus 8 plus 1 is 0. 12 minus 12 plus 0 is 0. 12 minus 12 plus 0 is 0. Then we have 4 minus 4 plus 0. This is 0. 7 minus 8 plus 1 is again 0. So this is a null matrix which we have to prove. We have to verify. We already verified it. Next step is to compute the A inverse. Now this is a very important step because this is going to come on and off when we go forward. So a square minus 4a plus I. Right? Please remember, always the I term has to be taken in the right hand side or on the other side. Then we multiply the whole equation, left hand side, right hand side, by A inverse. What do you get here? So A inverse can be multiplied in before and after, so it's up to you. The concept remains the same. So A inverse I'm multiplying, it can be before A square, it can be after A. But we know because of the properties, thus if you multiply A inverse or anything with I, it will be the same one. So A inverse I is A inverse. So A inverse cancelled here, minus 4i. Here also it gets cancelled, A minus 4i. So A minus 4i is minus A inverse. And negative you can always take here, and you can write A inverse as 4i minus A. Okay. So 4i minus a, when you multiply 4 with the identity matrix, you get 4004. So I'm writing it here, 4004. And then we have minus. And then what we have to write a 2312. So we get 4 minus 2 is 2, 0 minus 3 is minus 3, 0 minus 1 is negative 1, 4 minus 2 is 2. So exactly same thing has come. Okay. Now this is also a same question like this. So A square, that is you have to multiply the matrix twice. Means the same matrix had to be multiplied with same matrix, then 4a minus 42i. And as I said, 42i has to be taken on the right hand side. But before that you have to satisfy the equation, verify the equation. So put this A square, A, that is 4a, and minus 42i here. And then that has to be equal to 0. Now after verification, A square plus 4a minus 42i equals 0. And as I said, the identity element content or the term has to be taken on one side. So just multiply this all with A inverse. So A inverse, one of these will cancel A dot A inverse. So this gets, this is I into A will be A only. Then this also goes 4 into I. A into A inverse is I. And equals 42 I into A inverse. You multiply anything with I, the same element will come. So A plus 4i, I hope you will be able to do. A is already there, and just divide it by 42, or you can say multiply it by 1 by 42, and this is going to be a final solution. Same thing here, exactly same thing. And first you have to satisfy, then find the A inverse. Here also the same thing, but only one aspect here is x and y we have to find out before we go ahead and find out the A inverse. The equation is, or the equality is, A square minus x into A plus y into I equals 0. So first we have to find out x and y, put it in this equation, then we'll go for the next step, which is finding out of the A inverse. So I'll show you here only. A square minus x into A. So multiply this with x, 4x, 3x, 2x, 5x. Multiply this with I, means I with y. So wherever 1 will come, y will come. And then you equate it with 0. So 22 minus 4x plus y. 18 minus 2x plus 0. 27 minus 3x plus 0. 31 minus 5x plus y. When it equate to 0, 27 minus 3x equals 0. 3 9s are 27. And 18 minus 2x equals 0. Let me show you here only. 18 minus 2x equals 0. And that will give you 18 equals 2x, x is equal to 9. I'm just trying to suggest that we have the x value. Put it in any of the equation. So 31 minus 5x minus y equals 0. X is 9, 5 9s are 45. So y will be equal to 45 minus 31. and this is not 31 minus 45, it will be 45 minus 31. So when you get y equals 45 minus 31, it is going to be 14. And when you get 14, x and y is already computed now. Now you have to replace this x and y in the original equation, which is a square minus 9a plus 14i. So the final equation will be something like this: a square minus 9a plus 14i equals 0. Now multiply it with the inverse, and always take the identity element term on the right hand side or the other side of the it can be left hand, right hand, whichever you want. So a minus 9i equals minus 14a inverse. So a minus 9i computed and just divide it, or you can say multiply it by minus 1 by 14. This is your final answer. Same thing you are going to do here. There is no difference because here you have to find out lambda. Previously, in the previous question, I told you how to find out x and y. Here also, when you actually equate it, a square you need to find out. I hope you'll be able to do it. Lambda into a, so 3 lambda minus 2 lambda, 4 lambda minus 2 lambda, and minus 2 into I, 2 into 1001. So when you equate it, lambda will be 1, and then you can find out the a inverse. So this is also exactly like this. The only difference is it is not a square minus 3a minus 7. It is actually saying that this is satisfying the equation. So you'll put a in place of x. Similarly here, in place of x, you are going to replace 6576a here. And the same criteria, same logic which I showed you, you have to do it here. A is actually satisfying here. So a square minus 12a plus 1, you will not write 1 then. You have to write the identity element here. It will be I2. So now then you have to do the same thing which I told you, and then you can find out the a inverse. So this is a kind of a different question. So this is a 3 by 3 matrix. So we'll try to find out and how to solve this. The step will remain same. There will be a, it's not a raised minus 3, it is a raised 3. This is a raised 3. And first we have to equate, that is, first you have to show that this equation is equal to actually null matrix. So a cube, you have to multiply a, that is a 3 times. So I hope you will be able to do, because multiplying a 3 times will take a lot of time. So I'm just telling you that a into a, and then multiply a into a with a. So finally this will come. I hope you will be able to do it, okay? This is just matrix multiplication. So a into a into a. So once you do it, you will get a cube. That is 871 minus 23, 27 minus 69, and 32, negative 13, and 58. So this is your a cube. Once you do it, you multiply, you then subtract it with 6 into a square. A square is already there. So why not to multiply this 6 with internal element and then compute it. I'm just writing it, but I hope you will be able to multiply this and then add. Then we have 5 into a. Just multiply 5 with all of this. So 5, 5, 5. Then we have 5. 5 to the 10. 5 is the 15 minus 15. Then 5 to the 10 minus 5, and 5 is a 15. And then we have 11 I3. I3 is what? This is 1 0 0 0 1 0 0 0 1. This is your 11 into something, the I. So wherever 1 is there, you just replace it with 11. Now you have a simple addition of or subtraction of matrix, combination of matrix, addition, subtraction has to be done. So multiply this inside with 6, and then take the corresponding element and add and subtract. So I'll just show you how to multiply this 6. 6 to the 24, 6 this 6, 6 7 6 is 18, 6 8 is 48, 6 into 14, that is going to be 6 4 24, 4 to carry hand, 6 1 6 2 8, 84. This is 42, this is 18, again 84. Okay, once this is done, same thing, just see here, 8 minus 24 plus 5 plus 11. Okay, same thing you have to do, and you have to do it for all the 9 elements here correspondingly one by one. Okay, so once this is being done, you get that has to be 0. You will get a null matrix. That is just the you have just showed that it is 0. But in order to find out A inverse, you'll use this equation, that is you have A cube, same thing, right? Minus 6A square plus 5A plus 11 into I3, and this is equal to null matrix 0. Now multiply this with A inverse, every element. So A inverse, one of the A will cancel out, A square minus 6, one of the A will go, 6A plus 5A into A inverse will be 5I plus 11 into I3. So this 11 into I3 we have to take on the other side. And when you multiply this I with A inverse will come. So this 0 will also be multiplied by A inverse, and that will be 0 only. Now, as I told you, always the item has to be taken on the right hand side. So 11 A inverse, you can get this as minus A square plus 6A minus 5I. Now A square is with you because you have already calculated A cube. For that you must have calculated A square. A is already there. I is identity element. Put it here, do this simple addition and subtraction of the matrix, and finally you can divide it by 11 because 11 is already there on the left hand side. So final result is what I am suggesting you here. This is your final result, right? This is A inverse. Okay, this question is also similar to what we have done just now. So just have a look at the answer, and as I said, you have to multiply A with A with A. You have to multiply A 3 times. Then you have to find. You can also do the determinant, because you need to know whether A inverse exists or not. That will be an added advantage for you to ensure that the examiner knows you know everything. So once this is A cube is done, what you will do? Multiply this equation with A inverse. So you already have this idea now. Once you multiply this A inverse, this I3 term has to be taken on the other side, and that will essentially give you A inverse. So A is in A square minus A minus 3I minus A inverse equals 0. So A inverse you can take on the other side. You just have to perform A square minus A minus 3I. A square already you have computed. A already is given. I identity you already know. Simple matrix addition subtraction you have to do. So this is also almost similar to what we have been doing up till now. So this is kind of practice, There are so many questions. Just need to practice the same question with different numbers again and again. Now this question, this is A inverse equals A transpose. A cube also will come. A cube also will come. So A inverse we have to find out. And then we have to find out the A transpose. So if this is A, how are you going to find out the transpose? So A transpose will not be like this, that you transpose the matrix and then you keep that 1 by 9. No. When you have 1 by 9 here, well, it won't affect, but still you have to convert the row and column, that is rows to column. And then you have to multiply 1 by 9 inside. But since this is just a transpose, so I'm keeping 1 by 9 outside, and then row and column we are exchanging. So A inverse is adjoint of A divided by the determinant of A. In order to find out the determinant, just see scalar, but in order to find out the determinant, you cannot find out the determinant of minus 8, 1, 4, that is the inside matrix, and multiply it by 1 by 9. No, that is not the case. In order to find out the determinant of this, you have to multiply 1 by 9 inside. That is determinant of A. You cannot have 1 by 9 and then you compute the determinant of inside and then multiply. No. You have to multiply 1 by 9 with each and every element inside first. Then we'll take it outside. How? I'll just show you. If you multiply this 1 by 9 inside, you'll get minus 8 by 9, and then 1 by 9, and then 4 by 9, 4 by 9, 4 by 9, 7 by 9, 1 by 9, minus 8 by 9, 4 by 9. So just multiply 1 by 9 inside. This is a scalar multiplication. We know that in order to find out the determinant of A, we need to multiply this all inside. Now, we can take 1 by 9 from either 3 rows or either 3 columns. That's up to you. I hope you are understanding the concept. 1 by 9 you have to take. So, 1 by 9 will come from first row, 1 by 9 will come from second row, 1 by 9 will come from the third row, and this is almost similar to 1 by 9 coming from the 3 columns also. Essentially, the final output will be 1 by 9 into 1 by 9 into 1 by 9. That has to come out. Now whatever is inside, now you can take the determinant of it. So that is the catch here. That is the thing we need to understand. Now let us find out the determinant. So when we multiply this, you can open it using any of the row, any of the column, because doing it, making it 0 will take time. So minus 8, 4 minus 8, 7, 4. Here you have minus 1 and 4, 1, 7, 4 plus 4. Then 4, 4, 1 minus 8, 4, 1, 1 minus 8. Now this has to be multiplied by 1 by 9 into 9 into 9. So 4 4 is 16 plus 76 minus 16 minus 7 plus 4 minus 32 minus 4. So rather than going into the detail of simple mathematics, I'm just going to tell you the answer. Once you compute it, you will know that this answer will come as -1. So the determinant of A, we fix it and we finalize it to be -1. Once you have done it, now we have to find out the adjoint A. Determinant of A we have already found out. Now, see, first you have to multiply inside. Adjoint A, first you have to multiply this inside, and then, because you cannot have things taken out and then find out the adjoint of inside one. No. As I said in the first transpose case also, in other cases also, you have to multiply this 1 by 9 inside, that is the scalar multiplication, and then we will compute the cofactors. Cofactor can be only computed like this. So I am taking 1 by 9, making it a proper matrix. Now we are ready for the cofactor. So I will tell you certain cofactor. Let us take 2 of the cofactors. Minus 8 by 9. What is the cofactor? Cofactor will be, see, minus 1 to the power, the C11, so 1 plus 1 will come here. We have inside 4 by 9, this is 7 by 9, this is -8 by 9, and this is 4 by 9. So what do you get? Now you can take 1 by 9 common from either 2 rows or either 2 columns. So 1 by 9 into 9 will come, maybe from 2 rows or 2 columns. What is inside? 4, 7 minus 8, 4. So 4 4s are 16, minus become plus 56. This is 56 plus 16 is 72, 72, 9, 8, 8 9s are 72. You get 8 by 9. So I hope you got the idea of how this C11 has come. I'll give another option also, another description of C33. So C33 minus 1 to the power 3 plus 3, that is going to come as 1 only. And what will be there? As I said, 9 9 we have taken from 2 rows or 2 columns. So minus 8 1 and 4 4 will come. It is going to be minus 8 4 so 36 minus 36. Then minus 34, 32 minus 4, that is minus 36. So minus 36 by 9 into 9, so 9 4 36 minus 4 by 9 will come. So I have given you 2 of the cofactors. I hope you will be able to find out all the cofactors. So once you find out the cofactor, then you have to transpose it. You have to transpose it, and then you have to multiply this, or sorry, divide it by -1. Because why I said divide or multiply? Because together, because -1, if you multiply or divide, it remains the same. The result will remain the same. So this is how, once you transpose, this is going to be A inverse will be equal to A transpose. So I told you about A inverse equals A cube also. A inverse, you know how to find out A cube, that is you have to multiply A 3 times. So this is A, A square is this one, A into A. This result will come. Then A cube, you multiply A square with A. So you get A cube here. Okay. Now, once you find out the A cube, how it is going to be equal to A inverse? A cube we already found out. A inverse is what? Adjoint A by determinant of A. This is one way you can do it. But rather than doing it, we have a simple solution here. What is the solution? A cube is A inverse, you have to prove. But once you do A cube, you get certain value. And once you multiply A cube with A, I am just telling you to multiply A cube with what? A. So when you multiply, you have to do it by yourself. That is that thought should come into your mind. A cube into A. So once you do it properly, if you see here, that is going to come as identity matrix. A cube, if you multiply by A, you will get the identity matrix. So once you multiply something with A and that comes to identity matrix, that thing is going to be A inverse. I hope you got that idea. See, if you multiply here, do it by multiplying with A inverse. So A cube is A inverse here. Okay. So we tried A cube we already had. But in order to make it as A inverse, why not to multiply with A and show it to be an identity element? Because B multiplied with something, that is X, is I. So X has to be B inverse. Because B into B inverse is I. So when you multiply something with A and it comes to be an identity element, A cube is what? A inverse. Okay. So A inverse multiplied by A is identity element. This is the concept. In this question, we have already seen a question like this, A cube equals A inverse. So what we have to do here is, first of all, we have to compute the A squared. You take A, multiply it with A, so there will be a matrix multiplication. So once you are done with the multiplication, see, A square, when you multiply it again with A, you have to do it and show it. That is, whatever result is there, A square, if you multiplied it with A, the result will be identity matrix. Since the matrix is identity matrix, A square multiplied by something is equal to identity matrix. So when you multiply this A square with A and you get an identity matrix, that simply means this A square is nothing but A inverse. Then only A inverse into A will be equal to identity matrix, right? This is how it will be proved. Now next one is solve the matrix equation, and this kind of questions are coming, that is the different questions which we are dealing with. Many of the questions are like this, so you have to understand it very carefully. This is a 2 by 2 matrix X, and we have two matrices other than this X matrix, but we have to find out this X. So let us assume this first matrix as A, this second matrix as B. So how do we write this? A into X equals B. All in capitals because they all are matrix. Now if you multiply this with A inverse, what do you get? You multiply both sides by A inverse. A inverse and multiplied by A is identity matrix. So identity multiplied by any matrix, that will be same matrix, and right hand side it will be A inverse B. So you have to compute the inverse of first matrix A and then multiply it with B. So there is a very shortcut method. This is 5, 4, 1, 1. Let us compute the A inverse. Exchange this 5 and 1. The diagonal elements you have to exchange. And then you have to change the sign of other remaining elements. So 1 and 5 I have exchanged, and 1 and 4 I am changing the sign. And this is the inverse. This is a shorthand trick of computing the inverse. So just exchange the diagonal values and then just take the negative of other values and put it. So this is A inverse. See, you are free to do it by cofactor method only, but I'm just going to tell you, or I'm just telling you the shortcut method. So now you have this A inverse with you. Now you have to multiply this with B. This B. So this will be, this B will be 1, minus 2, 1 and 3. Okay. So let us multiply this row with column. So 1 into 1 plus minus 4 into 1. So 1 minus 4. 1 into minus 2 and minus 4 into 3, 12. Minus 1 into 1, minus 1. 5 into 1 is 5, plus 5. Minus 1 into minus 2 is 2, and 5 3s are 15. So what do you get? This is, the first one is negative 3. This is negative 14. 5 minus 1 is 4, and 2 plus 15 is 17. So this is your x. Now all the questions are like this only, because there are questions following which have the same kind of logic. So assume this to be a, this to be b, so x into a equals b. We have to find out x. So now you can multiply a inverse on the right hand side, that is x into a multiply with a inverse, here also b into a inverse. So a into a inverse will be what? It is going to be identity element, and identity element multiplied by x will give you x only, and this b and a inverse. So let us take b here, 14777, and a inverse is how to find out? Exchange the diagonal element, so minus 2 5, and just change the sign of the other two elements. So I am changing the sign, and thus you have to multiply this. I hope you will be able to multiply this. This is going to come. So the final answer will be this one, 3 1 1 minus 2. Now find the matrix X for which. Here we have 3 matrices which are already given. One matrix X need to be found out. So 3, previously we saw for 2 matrix, and we have to find out the other one. Here 3 matrices are given, we have to find out X. So assume it to be A, B, C. So what will be the final expression? AXB equals C. So first thing is, first we have to eliminate A and B from the left hand side, and that will come on the right hand side. So multiply both sides by A inverse, like this. A inverse into A will be identity element. Identity XB equals A inverse C. Now let us multiply both sides on the right hand side by B inverse. So multiplying it by B inverse. So this B inverse is going to be identity again. So identity multiplied by any element will return the same element or same matrix. So I and X will give you X only. This is the property we discussed already. And on the right hand side we have A inverse, C and B inverse. So X is equal to A inverse. A inverse is what? Just exchange these two. 5 here, 3 here, and change the sign of 2 and 7. Minus 2, minus 7. This is your A inverse. How about C? This is going to be C is 2, negative 1, 0 and 4. And what about B? See B. So B inverse will be exchange these minus 1, 1 and change the sign of minus 2 and 1. So this will be 2 and this will be minus 1. Okay, let us multiply these 3 now. I hope you will be able to multiply. Multiply two of them, multiply the result with the third one. And let me tell you the final result, that is going to be minus 16, 3, 24 and minus 5. This is your final answer. Now exactly same question like this. So there is no difference, only the numbers are different, the values are different. And as I said, you can use the shortcut method to find out the inverse, or you can use the long method, that is the cofactor method. This question we have already done in the past. Because we are already at 34th question, so we have already done this kind of question, but still I will give you a recall. So this A inverse need to be computed, and for that we need to see whether this determinant of A is available or not. Determinant of A, that is you have to find out the determinant of A, and that should come as non-zero value. If it comes to 5, for example in this case, then we can say that the determinant of A is not equal to 0, A is invertible. How about this? A square minus 4a minus 5i. So now you have to multiply this all by, see, this is 1 0 0 0 0 0 1 0 0 0 1. This is identity matrix. So A square you already know. You have to multiply A with A. Then you have to put A multiplied with 4, and then multiply this identity matrix with 5. So this is going to be 0. When you compute this is just a recall. Okay, we have already done this question. So A square minus 4a minus 5i, this is going to come as 0, which you see here in the solution also. But now we have to multiply both sides by A inverse, because we have to find out the A inverse. So 0 multiplied by anything is going to be 0. So A inverse, multiply this. So A inverse multiplied by A square is A, minus 4 into A inverse is I, minus 5 A inverse I is going to be A inverse. Anything multiplied by I is going to give you the same thing. So it will be A inverse. Now we have to compute this 5A inverse. So 5A inverse is going to be A minus 4I. And I hope A is already there. 4 into I already showed you. So it will be 4, 4, 4 here. And just subtract. Simple subtraction you have to do. And divide it by 5. Because this is 5A inverse. And that is going to be your final answer, 1 by 5. Okay, this question already we have seen. But I'll give you a hint here. If you are, you have not done that question, or you might not be able to recall. So AB inverse is nothing but B inverse into A inverse. AB inverse is equal to B inverse A inverse. So what is A inverse? This one. What is A inverse is already given. B inverse you have to find out. So B inverse, B is already given to you. Take the cofactors, then take the transpose of that cofactor matrix, and then divide it by the determinant of this B. Determinant of B is 1. Let me tell you. And just multiply these two matrices and you will get the final answer as AB inverse. This is A transpose inverse. So there is a property which we discussed earlier, and this A transpose inverse is nothing but this is equal to A inverse transverse or transpose. So first we will find out the A inverse, and then whatever the result is, we will take the transpose of it. Okay, so A inverse is nothing but adjoint of A divided by the determinant of A. What is the adjoint of A? You already know how to find out cofactor matrix, and then you have to divide it by the determinant. That you can find out. And then A inverse, once you have computed, you just have to take the transpose of it. So I am just saying that A inverse you are able to find out. Then you just have to change the row to column, which I am showing you. This row to column, row to column. And that is going to be your final answer. Next one, A is there. So first thing is you have to find out the adjoint of A. Then you have to find out the determinant of A. That is the only thing you have to find out and put it in the equation. But we have to find out first the adjoint, because adjoint will be used in this equation also. Adjoint is simply you take all the values, try to find out the cofactor of those values, and once you have computed the cofactor, you have to take the transfers. That will be the adjoint. For example, let me tell you this, just recalling it, because we have already done this question, but this type of question. But let us say we need to find out the cofactor of C11. So minus 1 to the power 1 plus 1. And whichever is remaining, the row and column of C11 needs to be forgotten. Only 1, minus 2, and minus 2, 1 will be there. So minus 1 to the power 2 is positive, and this is 1, minus become plus. This becomes, no, it will be minus. So plus and minus, 1 minus 4 is minus 3. So this is how you have to find out all the cofactors, take the cofactor matrix, and they take the transpose. And the transpose is going to be your adjoint. So once you are done with this part, that is the adjoint you have computed, now determinant also you have to compute. Determinant is what? Easy, this is 3 by 3 matrix. You can easily compute. You can open it with any row or column. So once this is done, then A is already there with you. You have to multiply with the adjoint A. Adjoint A we have just computed, and this will be equal to determinant of A into I3Y, because the result will be, you see the diagonal has 27. So once you take the 27 outside, it will be identity matrix. So this 27 is nothing but the determinant of A. So you can easily say that A into adjoint A is equal to determinant of A into I3. That is your final result. Now this question, again the same thing. A inverse we have to find out, and A inverse you have to show that A inverse is equal to this expression. So A is there, A inverse is adjoint A by A, take the cofactor matrix, take the transpose. Once you take the transpose, divide it by the determinant of A. And once this is done, then you have to find out A square. That is, you have to, A square, whatever is A square, leave it. Now multiply this A with A. Now keep this A square here. Subtract it with 3 into I3. I3 is what? Diagonal will be 1, 1, 1. That is 3 by 3 matrix. Diagonal will be 1 by 1. Other values will be 0. Now, just subtract these two and divide it, means multiply it by half, that is you are actually dividing it by 2. So whatever is the result, you will see that once you compute it, it is going to be exactly equal to the A inverse. Okay, this is your final. There is no trick, there is no logic, this is just simply computation. That's why you can have a look and observe the result. Okay, this is all about this discussion. Thank you so much. Take care of yourself.